Hey guys, welcome back. This is going to be episode number 5 of the Duramax Camaro swap. In the last episode we worked on the cooling system, got it all finished up, and in this episode we're going to be working on the fuel system. So we're going to get the fuel pump, putting out the PSI we need for the motor, we're going to get the return lines done, fuel filter mounted, all that kind of good stuff. Everything that pertains to the fuel system on the car, we're going to get that all done right away, so stick around. The first thing I want to do with the fuel filter housing here is I got rid of the 2 metal pipes that were in there from factory. They just slide out, they're kind of just pressed in, and I tapped it out to a 1/4 inch pipe thread. Then I was able to put in these 2 fittings here that go to 5/16 hose, and that will just position them and point them in the right direction because the location that I picked on the car interferes with the 2 factory outlets, or inlet and outlet. So this kind of will solve that problem. It puts, I got 2 90 degrees to put on them here, you can see, and that won't interfere with the car. This is the location I picked for the fuel filter. It's kind of similar to the factory Duramax. It's on the passenger side in behind the fender liner. So you'll be able to pop the fender liner out when you need to change the filter. It's not horrible to do. The headlight bracket is what interferes with those 2 lines coming out of it, which is why we needed those 2 90s. But kind of with a rough idea of where it wants to go, or where I want it to go, then I'm going to use some cardboard here to trace out a rough bracket and kind of get started on how we're going to design and make this mount to mount the housing under here. The lower hole there you can see goes into actually factory threads on the frame rail, and with the rough shape of the bracket made on the cardboard, I can go ahead and mark the 2 top mounting holes. Those will go through the top pinch weld on the frame and mount to the filter assembly itself. The CAD software I use is called Freecad, and what I do now is I'll measure each of the sides of that cardboard to get lengths, and I'll enter those lengths in here and try to draw the shape out into Freecad. And then I can go ahead and measure the angles of each of the corners, and I'll transfer those angles into there, and that could give me the base kind of shape of the bracket. At the top of the bracket, it needs to jut out so it can mount up flush against the pinch weld. So I add that part there so it sticks out, and then I use the measurement of the pinch weld, or to the height of the outside frame, to determine that height. Then I can add all my mounting holes, and then from then on I basically just smooth out all the corners and make it look pretty. Once I'm happy with everything, I upload the file to an SD card and I'll put it in the 3D printer. And 12 hours later, this is what we end up with. It looks like it turned out pretty good. Surfaces are pretty smooth except for that top surface. I use PETG for it. Sometimes they can end up with a rough surface on top, but a little bit of sanding can fix that up. I'll just get it mocked up against the fuel filter here so you can get an idea what we're going for. Those 2 holes line up with the mounting holes, and that'll be kind of against the frame rail there. So kind of like this. It actually is going to work out pretty nice. That bottom bolt just threads right into that factory threads on the frame rail, like I said before. That'll hold everything in place. The 2 top holes on the pinch weld there, I had to drill those through myself. Those holes weren't there before, but I was able to just drill them through pretty easy. Slide a couple bolts in from the inside, and we'll get everything bolted up. And here's the final install. You can see our 2 90-degree fittings that get the hoses up out of the way. Lots of room between the filter and the frame rail. It's going to be easy to get at too from underneath to change it. And if we jump up on top, you can see it's still easy to access the primer feature if you ever needed to use that. We have electric pumps, so we won't really need it, but everything turned out great and I'm really happy with it. So the next thing to tackle is the return fuel system. This car has, or the LML engine has, a return line coming off the rail, a return line coming off the CP3, injector return lines, and then also a return fuel temperature sensor that needs to go in as well. And then those all need to connect together and go back to the fuel tank. So my plan for all this is to build a return line fuel rail. That's this aluminum tube you see here. I've already drilled it all the way through, you saw that. And I've now tapped the one end to accept the fuel rail temperature sensor. I'm going to go ahead then and mark where I want to put the other fittings. Try to make them nice and even so it looks good. And the rest is all going to be pipe threads. There'll be 3 fittings on the top here, and then 1 fitting in the end there. That'll give us all of our connection points for all the return lines, and then the one off the end will go back to the fuel tank itself. Here you can see I'm just drilling them out to a little bit bigger size. Anywhere where I'm going to put the pipe threads, they're going to be 1/4 inch pipe threads, and all the fittings I'm using are 1/4 inch to 5/16 hose barb, except for one of them is going to be an 1/8 inch hose barb, and that one will be for just the injector return lines. All the other lines are 5/16, even the one going back to the fuel tank is 5/16. I've had the car running like this for a little while, and it hasn't been an issue at all. I don't think there's any restriction, so it seems to be working good with those line sizes and these pipe thread sizes. Alright, with all the holes drilled and tapped and the fuel rail cleaned out, actually everything turned out really good here. I used a couple of 9 degrees on the top just to keep things a little neat and tidy. Just get everything assembled, get everything tightened up, and then I'll show you here it installed in the car. Alright, so here's to get our baseline for pressure. I got it wired straight, let the pump run, and we're reading about 85 psi. That's deadheaded, pump on full time. We've got to neck that down to about 10 psi max. So I'll try doing that by changing the internal regulator that's in the pump, or else do an external one that will vent and bypass to hopefully one of the vent lines at the top there. We can use that. And then the only other thing we need to check is it's got the Venturi and a jet pump built inside that draws fuel from this side of the tank and brings it over. So once we get it necked down to 10 psi, you have to run it for a bit and make sure it's still pulling it over from the other side of the tank, so we don't run out of fuel with a 1/4 tank, because in my previous setup, that is what happened when I had this just pulse width modulated down to 10 psi. So anyways, I'm gonna get the pump out, do some modifying, play some things, and see what we can come up with. So I cut the back of the regulator off. There's just a spring in there, very heavy spring. And then here's the part I cut off. So hopefully what we can do is just replace that spring with a weaker one, and then that'll regulate 10 psi, or possibly extend this a little bit and put an adjuster screw on the back with a washer, so we make it a little bit of adjustable too, so we can, you know, be able to set it down to 10, 8 psi, somewhere in there. So I'm going to put this back in and just run it with no spring and make sure we can get the flow down to that. Because if I put this back in with no spring and it still has too much pressure, then that thing just pumps out so much that, you know, we'll have to like drill out this orifice or something to make it flow enough to reduce the pressure. I'll pop this in, we'll give it a try. Okay, I reinstalled it with no spring, no back on the regulator. This is where we end up. We're getting close, 17 psi. My next step before I put everything back in the car will be to hook it all up to the car and put a pressure gauge on it and actually run the car for quite a while. I just want to have a tank mounted out here on the bench, but I want it fully plumbed into the car, and then I want a return line from the car going into a jerry can. Then I want to run it for a while, measure the return, like how much it's returning, make sure that's good, and make sure it's not going to be sucking the one side dry. And then that'll be a full test of how it will act once it's installed back in the vehicle. And if that passes, then that's the final thing to do. We can put it all back together, and the car is pretty much running and driving at that point. Okay, so now I got both sides full of fuel, the modules out, and then filled them. If this was underneath the car right now, that's how it'd be plumbed. If it was plugged into the car right now, this is what would be happening with the key on. It would just be getting direct power to the pump, no more fuel pump control module. That's going to be eliminated from the system from now on. The return line is still plumbed into the filler neck there.
It connects from, it uses that evap line, the factory one, and I ran a hose up to the vent line on the filler neck, and that's where it actually returns the fuel into the filler neck and back into the tank. And then I have the evap system kind of bypassed, and it's actually the 2 evap lines on the top of the tank are what actually vents the tank now. So any fuel that returns is going to come out of the filler neck hose here and just go into the pail. So actually this pump actually plumbed into the system properly. It's more like 14 psi. Okay, so 15 here at standing. I'm going to fire the car up and we'll see what it moves down to. Alright, so I ran it until 20 liters came out of the return line. Pressure stayed good throughout the whole run or idle or whatever you want to call it. Last thing we got to do is pop this side off and just make sure that the fuel was drawing over to that side. So this should be down a bit. It does take a while to draw it all over. You got to remember, like, that fuel normally was returning back into the tank. So it takes a very long time to return everything over to the other side.
Basically, we just want to see that it's gone down maybe a couple inches, not even. All right. So before, I took the jerry can and poured it straight into here to make sure this side was full. And you can see this side is already more than halfway down. So we know now that with this pump running full time, with the regulator bypass like that, we are going to create, it was about 7 PSI at idle, which is exactly where Duramax is happy. And our Venturi system is still drawing from one side of the saddle tank over to the next. So what that means is I'm going to get everything cleaned up and ready to go, and tank goes back into the car, and the fuel system is going to be complete. All right, so another thing that's got to be addressed with the car is the fuel filler neck is too small to fit the diesel gas pump nozzle. If you have a look at it there, you can see the tube itself is big enough, like the filler neck itself is big enough, but it kind of necks down for the venting and all that junk. So I'm just going to take a air hammer and knock all this out, open it up, and then I'll be able to go to the pump, and I won't have to sit here with the thing sticking way out of it, making it hard to fill and spilling. All right, let's do it. Okay, there it fell down there. Also have to grab a magnet and fish it out. Now make sure you do this with the fuel tank removed, otherwise you might get that piece stuck in there. At least right now it'll be easier for me to get the filler neck out and remove it, but grab a magnet, get it out of there. And there it is. I'm gonna take a flap wheel on a die grinder and probably just clean up some of the kind of sharper edges. Blow some air in there, make sure the debris comes out the bottom. 100%. Okay, with the fuel tank back installed in the car and everything else pretty much wrapped up, the last thing we're gonna have to do is wire a relay in place of this fuel control module. So remember, we got the pump set that it puts out about 8 PSI running, and that's with full power every time the key is on. This fuel control module is going to try to give it a pulse width signal, and it's going to try regulate the pressure according to what's programmed to. We don't need that anymore. Now, if you remember looking at the wire diagram, this fuel pump control module has grounds, it has a battery power, and it also has an ignition power going to it, all on their own fused circuits, and we're going to use those circuits to power the relay. So first thing I'm going to do with the relay is put an extension on it so that I can locate it back in the trunk so it's easy to get at instead of behind this panel, because this is annoying. And then we'll go ahead and make our connections. We're going to use the ignition to trigger the relay, we'll use a ground on the other side of the relay coil, then we're going to have the battery power going in, and then of course the power wire going to the pump itself. So I'll get started with that relay, and then I'll come back here and tap into the wires we need to tap into. I'm still a big fan of solder and heat shrink, and I know a lot of guys are against it, and they'll argue to death on the internet about using crimps, but I always solder my connections. A good solder, make sure you don't get it too hot. I have never had one fail on me, crack, break, anything like that. Then just make sure you get some good quality dual wall heat shrink, warm it up, and you're going to have a connection that's good as a factory connection as far as I'm concerned. Here's where I located the relay. It's right beside that little junction box in the trunk there on the passenger side, and then I just ran the wire up along the factory harness and through that hole right there. Nice and easy. Okay, so I got everything connected up here. So remember, we got battery from here feeding the relay, and then back from the relay you go in on the gray wire which goes down to the pump. For the relay ignition power, that's a pink wire. Then there's a black ground wire which will ground the coil in the relay, but then also you need to tie the pink wire that goes down to the pump. That's the ground for the pump. It's weird, I don't know why gray is power, pink is ground, but GM kind of got those backwards if you ask me. But one other thing we can't forget to do is loop the CAN bus system that goes through the fuel pump control module. So these two wires, this is the data bus for all the communications in the vehicle. So they used to go into the module and then come back out again. They continue on. Actually, I think they might actually end right here. I see a terminating resistor right here. That means it's the end of the line. You gotta make sure you loop those so that you can still communicate with whatever else is in the line, or reconnect so that terminating resistor is still present. Otherwise you'll have lots of communication issues. So I'm just gonna go ahead and I'll finish zip tying this now. I'll tape it up a little bit, clean it up. I can hit the key on and you can hear the pump running. So everything works good. So I'll just finish that up and I can put it back together. Alright, so that's gonna wrap it up for this video. Fuel system's complete. Next video is going to cover the intake system going from the turbo like to the air filter. Just that simple intake pipe, like the cold air intake, whatever you want to call it. So I'm going to start working on that. Hopefully you guys enjoyed the video, and if you liked it, hit the like button. Subscribe if you want to subscribe, you know, all that good stuff. Leave a comment. Got any questions, feel free to ask them. I'm always in the comments answering anything I can. So thanks again, and see you in the next video.